Welcome to the recording of the web seminar Healthy Buildings, Contaminants and Pollutants in the Circular Economy. This was the final web seminar from the online event series NaturePlus Europe Healthy Buildings 2020. Thank you for taking the time to watch.
Of course, we are not talking about healthy building in itself, but yes, our connecting topic is contaminants and pollutants. And as you know, or we will see that there are a lot of topics or parameters which correspond to the aspect of healthy building in the same way as to the aspect of circular economy. What I won't be talking about today is the healthy impacts on, in regard to pollutants and contaminants in the end of life of the buildings, but I will look at contaminants and pollutants impairing recyclability of building materials. My references for today are building assessment tools in Austria and Germany and ongoing research, corresponding research projects, mainly research cooperation with the German BMI BBSR. That's the BBSR is the Federal Institute for Research on Building. And this is assigned to the BME, the Federal Ministry of Interior. And they are running a criteria or a building assessment tool called BNB, Assessment System for Sustainable Building, Bewertungssystem Nachhaltig Bauen. And with therein there is a criteria profile called BNB 4.1.4 number, and this criteria profile aims to optimize buildings in the design process so that they are optimally prepared for dismantling, separation and recycling, and it will leave behind as little waste as possible. And we have the same building assessment, or not the same, but a similar assessment system in the Austrian system called end-of-life indicator. And in this research cooperation, we try to redesign this criteria profile with the experiences we have in Austria, and with a lot of research work and interviews. And one starting point for all these end-of-life indicators is the contaminants and the pollutants in building materials. And of course, the natureplus guidelines are also important source reference for my today's speak. So today's focus is I want to give, sorry, I'm a bit busy because I'm host now and there are people coming, but it's nice that they are here and I have to let them in. So today's focus is, I want to start with a definition of contaminants and pollutants. Then I want to go into more detail of how do contaminants impair the recovery of materials, then of how do pollutants impair the recovery of materials. Then I would like to present you the classification metrics we developed for end-of-life roads, and then I would like to give you a short insight in the next steps we, IBU and natureplus are planning to do. The basic approach of all these end-of-life assessment schemes in various building assessment tools, not only in Austria and Germany, is that they start to apply deconstruction scenarios on building elements. Usually, these building elements are deconstructed virtually, depending on the joint techniques between the various layers. Are the different layers separable from each other or not? How much effort does it take to separate the layers from each other? Depending on this, we will have different waste fractions with different contaminants from adjacent layers, and in the next steps we look at these contaminants and pollutants of the waste fractions and try to evaluate them, and this will be the focus of the talk today. And yes, and these contaminants and pollutants are assessed, evaluated according to to various end-of-life scenarios or end-of-life routes. Yeah, in principle, we have not so many possibilities in end-of-life. The waste law starts with avoidance of waste. That's something that is very complicated, if even not impossible on product level, to avoid a product. So we don't focus on that now, but we start with the second priority of the waste law, with reuse and further use. In our assessment tools, we don't distinguish between reuse and further use, since reuse or further use at all is, at least in the German-speaking countries, yeah, something that is very seldomly done in today's recycling disposal practice. It's maybe more usual in Netherlands, as far as I know, or Belgium, but not so in the Austrian-speaking countries. Reuse, further use is something a bit special, because usually the reused product or element doesn't reach the waste status. It's still in the product status. So the waste law also calls this preparation for reuse, not just reuse. Whereas in the recycling paths, the building material usually becomes end of waste status, becomes waste status, and then to be recycled, it has to regain product status or end of waste status, depending on various conditions, on what we will look at some today. Yeah, and then yeah, in principle, we have, except this reuse, 3 possible end-of-life routes: recycling, incineration, or landfilling. And within these principal routes, we define some classes, always starting with the top class. I will come to that later on. So to our topic, contaminants and pollutants. In Germany, we call these contaminants Störstoffe and pollutants Schadstoffe. I'm not 100% sure if the terms, especially the term contaminant, means 100% the usual terms in English. But what is meant by contaminants, these are residues from adjacent layers, so not from the building material from itself, but from adjacent layers that can impair reuse, recycling, or thermal recovery. And examples for contaminants are gypsum-based plaster, for example, on concrete. So this gypsum-based plaster impairs the recycling of concrete to aggregates for new concrete or for road layers or so. So it has to be given away before recycling, and the effort is quite high to get rid of this gypsum contamination. Or another example is coatings on wood-based materials that could impair the recycling, and it could be forbidden to recycle wood-based materials if the coating, for example, contains heavy materials. Yeah, it's important to understand that these contaminants are from adjacent layers, so it's quite difficult if you talk from the natureplus or manufacturers side of view. So it's quite difficult to deal with these contaminants on product level, since we don't know how this product will be built in the building. So we just can make some recommendations on building level how this building material should be combined with other layers. I will come back to that later. Yeah, and on the other hand, we have the pollutants. These are really ingredients of a building material. These pollutants can be either hazardous substances, like, for example, flame retardants in polystyrene, or non-hazardous substances, but which are nevertheless negative for recovery of materials. An interesting example for this are the carbon fibers in concrete. So carbon fibers are quite harmless fibers in manufacturing, and they help equip concrete with excellent technical functionality. So, for example, concrete can be thin now. So, in a first look, that looks quite positive in as ecological aspects. But it has turned out in some research projects in Germany that if you break concrete with concrete fibers, then these concrete fibers can become cancerogenous in sense of dimensions. WHO, these WHO fibers. That's one problem, and the other problem is that the disposal enterprises nowadays have not the right equipment to break this concrete, so they have big problems to even dispose the concrete, because these fibers hinder the concrete to break down in aggregates as they usually would do. So to have a look on how contaminants from adjacent layers can impair recycling, I give you the example of concrete. My colleagues in Germany made a lot of interviews with certain disposal companies, and asked them how they deal with typical adjacent layers on concrete, which is problematic, which layer is not so problematic. In the end, you see the carbon fibers we have just talked about. That's the most problematic thing we found out in our research work. Of course, that's a pollutant, that's not a contaminant. And yeah, according to contaminants, we have some contaminants which are not so problematic according to the disposal enterprise, like, for example, small amounts of bitumen primer, or small amount of gypsum plaster filler, just a very thin coating on the concrete, or other small coatings. In these cases, the disposal enterprises don't make too much effort to separate these adjacent layers or contaminants from adjacent layers, but recycle them all together with the concrete. And on the other hand, we have some layers which are more or really problematic in recycling. If we have a high amount of bitumen mass, or ceiling sheets, or gypsum plaster, or thick coatings, as for example resin, synthetic resin floors, Epoxyharzbeschichtung, then it's either really hard to separate them, for especially hard in an economic sense of view, to separate it from the concrete, And this concrete is either recycled to, not really recycled, but reused for fillings or something like that, or is landfilled. And of course, the best thing is if there is no adjacent layer or the layers are easily separable. So as I've mentioned already, strategies against contaminants is really difficult on product level since it's more design strategies that have to be applied. So as avoid, replace non-separable adjacent layers. So for example, use loosely laid sheets instead of glued sheets, or yes, replace interfering adjacent layers, as this mentioned gypsum plaster with other plasters on concrete, or even search for a better available technology. So for the same function for a floor or ceiling or so, you could search for something like the best case building elements. And what we can do on product level, either on manufacturer side or natureplus or consultant side, is to give recommendation for best case building elements. So recommendation, how can my product, this product, be used in construction, so which are dismountable, which joining techniques can be recommended so that I can dismantle it easily. Yes, we can give information about substances from adjacent materials, adjacent layers that would impair recycling or that would not impair recycling. So the recommendation according to this replacement of interfering adjacent layers, and of course information about dismantling concepts, take-back concepts, and recycling concepts in dependence of adjacent layers. Yes, this was the topic of contaminants, and now we are looking more in something that we also have to deal with directly in natureplus are pollutants. We will separate this topic in two aspects. One side is pollutants in recycling, and the other side is pollutants in incineration. Pollutants in incineration is a bit easier because in principle the parameters are more or less the same, independent if where this waste burning waste material, waste fuel can be burned. What you can see here is the limit values of various incineration plants according to the Austrian incineration regulation, Abfallverbrennungsverordnung. What you can see here is different parameters, heavy metals, sulfur, halogenic compounds, chlorine in particular is regulated, and other contaminants. Yes, then you can see that there are various limit values depending on where the fuel, secondary fuel is burned. So for cement plants, the limit values are a bit higher than for co-incineration plants, and the strictest limit values are for substitute fuels. These are fuels, they are processed and have end of waste reach and are then sold on the market, sold as like products. That's why they have the strictest regulations. Yeah, and if we look now on our natureplus parameters, which we usually measure by every product, these are the limit values for particle boards, for example, then we can see that the limit values for natureplus products are significantly below all these limit values of incineration plants, and that we can say that natureplus awarded products will surely fulfill limit values for incineration plants, I would say, throughout Europe. We measure more parameters than it is required by the incineration regulation, and we are far beyond. So if pollutants together with natureplus products will always be lower, what could be contaminants, and that has to be regulated in the design stage. So what we made then for our end-of-life indicator, we combined the list of the waste law, German and Austrian ones, and combined this with eco-labels, and combined pollutants and contaminants, possible pollutants and contaminants, and made this list of parameters where we added, for example, bromine and fluorine to the list, which is required just by law. Just only look at chlorine. Yes, and so we added some important contaminants which should be regarded at the end of life of building materials, and we defined limit values for them. I won't show you them in detail now because they're still in discussion, especially with industry. And together with material characteristics, this leads to such a classification matrix for incineration. These material characteristics are the main characteristic defining energy content. These are heating value and bulk density. If both are high, that's the best grade, of course, for incineration. If heating value is high but bulk density is low, then we define the medium class. An example for these are insulation materials. As you might know, the heating value of polystyrene, for example, is very high, more than 40 megajoule per kilogram. But the bulk density is so low that the energy content of the material that you put in your oven is not that high, but rather low, up to medium, so you don't get so much energy out of a PS insulation panel, for example. And and the low is, of course, if also the heating value is low, then is class low. And in these classes we have various subclasses depending on the pollutant, on contaminants. Very pure materials get the highest grades. These are substitutes, fuels, and the waste status could be reached. And then depending on how many problematic pollutants are inside the material, then the grade it gets down and down. And if the heating value is medium, then everything is shifted to the right side. And this first class we would regard as recovery, and the second two classes are just thermal disposal. So the focus is on disposal and not on energy regaining energy. Yes, that was pollutants in regard to incineration. The second thing is pollutants in regard to recycling. That's a bit more, or that's complicated because we have various recycling requirements depending on the building material. So you have other recycling requirements for concrete, as for waste, as for wood, as for polystyrene, as for steel or whatever. We have various parameter lists depending on which building material we're looking at. I would like to give you an example on wastewater, and we did a lot of research work on the most important building materials and the requirements they have for recycling. So in regarding wastewood, we have in Germany the wastewood regulation, Haltholzverordnung, which defines some categories of wastewood, so from naturally wastewood to treated with wood preservatives wood, and only the first two classes, naturally or slightly treated wastewood, may be recycled, and the other one have to be burned. And for recycling of wastewood, the German Haltholzverordnung wastewood regulation again gives some limit values, which are now significantly lower than that we've seen for incineration plants. Logic, I think. And again, if we compare this with the natureplus limit values for particle boards, for example, then we will see that a lot of the pollutants, the limit values for a lot of pollutants are much, much lower in natureplus, and some are also lower, not so tremendously, but are all limit values of natureplus are lower than, for example, these limit values of wastewood regulation. So again, we can assume that natureplus products will also meet the requirements for various end of waste regulation for various materials. So again, we made a classification matrix. These are the various gradings of recycling. So reuse and closed loop are the top recycling routes. Recycling to valuable product, but not in closed loop. And if you need, for example, binder to make a product, you cannot recycle the product in its own recycling cycle, then this is the second step. And the lowest grade is if the product is downcycled, filling of cavities or land heaps or something like that, or if the recycling product itself is not recyclable. And if you need a high effort to recycle the product, high effort in terms of energy, for example, energy, and this is compared with the energy you need to produce the primary raw material, which should be replaced by a secondary raw material. Yes, if you need high effort in terms of energy or chemicals, then the grading is again shifted to the right side. Yeah, this classification is done according to the pollutants and contaminants in the building materials, or the virtual building material waste, and also, of course, according to the recycling technology or the recycling processes which are known for the product. And if we today, in the design stage, design of a building or design of products, look on the state of practice on the possibilities for recyclability or so, we always look at the state of practice and technology. And the state of practice and technology in regard to recycling technology in particular is very much dependent of building materials which were used in the past, past 50, 100 years, let's say. So disposal companies have experiences with these materials, but they have no idea how to deal with today's materials, or some of the today's materials. Let it be the carbon fiber concrete, let it be the bricks with infilled insulation materials, because they had no reason until now to develop equipment. But that must not say that they could not develop a special equipment. If you look at LCA prescribes you, requires that you, if you make your end-of-life scenarios, you have to look at the state of practice and technology. We think that we have to do both. We have to look at the state of practice and technology now, but we also have to look at least at the near future, since, as I've told you, the experiences of the disposal companies are with old materials, and since our state of practice is very much infected by economic conditions, landfilling fees are still too low, there's too less pressure on recycling, at least this year. Maybe there will be some better situation in the next years with all this circular economy strategies. But yeah, nowadays conditions will not meet entirely the future conditions where our now designed buildings and now designed products will be hopefully recycling. So we do also look at upcoming state of practice and technology. An example for this is if we look at gypsum plaster boards in Austria and Germany, they are landfilled or used at filling for filling for heap, downcycled to a very, very high grade. Also, they have a very, very high recycling potential, and in principle can really be closed loop recycling. There are some activities going on in Germany. There are some disposal companies, big disposal companies, which can produce really, really high-grade gypsum powder out of gypsum board panels, and there are activities concerning targeted collecting of gypsum board. So there's something in the air, and that's what we want also to consider in our end-of-life indicator. And we try to do this with this technology factor, which shall describe how probable the technology will be there in some years. So that's very, very probably with 75%, and little probably 25% when it's only tested on a small scale, and there's some technology where we think this is not sustainable at all. So I should come to the end, I think. So I will speed up a bit. This is the classification matrix where we put all these end-of-life routes together, the recycling routes, the incineration rules, and the landfilling rules. We haven't talked about that yet, but of course they are in the end of the grading systems. As you can see, we had to decide how we would create recycling versus incineration, and so recycling with effort is created the same way as high-level incineration in the moment, but this is still in discussion with BBSR, with industry, with stakeholders. Yeah, and with this we can make a classification for each building material based on the recycling technology now and the upcoming recycling technology. So to end, in the end, I wanted to show you some the next steps. First, according to this end-of-life indicator, that's a project funded by the Zukunftsbau, Future Building, German Ministry. This project just started. We have partners from TU München and Hochschule Ansbach. They have been researching with us for many years. And there we want to, based on this classification matrix, we want to build up a whole system for assessment of whole buildings. We have various ideas how to do this, and we now are evaluating them, how it works in practice and on building level. And we will build up various tools around this assessment system with a material database. Yeah, I've seen Ibu hob die Hand. Okay, but maybe this was okay. I've had a sign from Zoom. Sorry. Yeah, that's what we are doing here. Then another project is Building Cycle together with the Holzforschung and OFI. Holzforschung is the lead. That's a ACR, strategic project, Austrian Cooperative Research. We are a network of non-university research institutes, and there we want to build up an analysis laboratory to determine pollutants from buildings that should be dismantled. And there we want to, on-site or in laboratory, make very quick analysis on pollutants of the of critical building materials, and want to find a way in addition for discharge of pollutants. Another project is BIM BECO, where we want to make product templates according to the BIM standard, which describe environmental aspects, for example, content of pollutants and circularity. And this shall be integrated in our database, Baubook. So that we have this content inside Baubook, but we have no BIM connection yet, so we will apply this standard. Yes, and finally in natureplus, and that's with that I want to end my speech. In natureplus Criteria Commission, we plan a new guideline on, that's still a work title, for assessing the circularity of building materials. Yeah, and we are now, based on the various webinars we had in the last month, we are now formatting a working group. Yeah, and we'll start with the first drafts hopefully next year. So sorry that I've talked that long, but thank you for your attendance, and please give me your questions.
So, Conde,
yeah,
thank you very much for showing us these rather difficult approaches, which seem to be necessary to go on in this endless discussion. As we have no questions in the chat, I will, but I have a question, but I want you, dear participants, invite to ask if you have some questions to these approaches. My question to you, Conny, are you optimistic that we will get rid of these contaminants and pollutants, that they will disappear from the building industry, from the building sector very soon, or how long will it take? What do you think?
maybe the sooner in the product design. I think there are a lot of activities from the European Commission regarding circularity, regarding eco-design of building materials. So I think there will maybe a lot of things going better, or there will be much more pressure on avoiding pollutants or impairing materials on the building level. In terms of the nowadays built environment, I'm more skeptical. We will be accompanied by, for example, HBCD, the flame retardant in polystyrene, for a very, very long time. That was one motivation for our Baucycle laboratory. How can we very quickly analyze if this flame retardant is in the building material? So, yeah, hopefully in the product design soon, and with the help of natureplus, maybe sooner. And yeah, with the still existing buildings, yeah, we will have to do to deal with all these contaminants for a rather long time, I think.
Okay, so we hope it will work sooner than we all expect, because there are some really unwanted substances nowadays in building materials. Yeah, it's fine. We have products with which fulfill the natureplus criteria or which are certified, so we could already avoid these problematic substances. But I think you all know that, and I'm happy that you joined us this hour. So, or Gundi, do you want to say something else? Because nobody is. Oh,
maybe somebody doesn't want to make a question, but input.
Yes, I have one. Thank you. And I will read this now. A technical question, referring to the slide, state of practice in technology. So you mentioned that companies don't know how to recycle bricks filled with mineral wool or polystyrene, but not the recyclability of standard facade insulation, namely bricks, concrete plus polystyrene boards, also mit dem Verbundsystem. I know the complaints, but I think they lack evidence. Do you know any study that proves that the first is harder to recycle than the second one?
Yeah, I'm convinced that the first is better to recycle than the second one. I'm convinced on that. But the feedback we got in our interviews of the disposal companies was that they don't have the equipment now, because they never had the question to separate this brick with the infilled insulation materials. But it's logical that I cannot imagine that there is no technology available to separate these two things. But now they don't have it, and so it's a problem for them. But I think it's the right way to go, and not to stick to that, what is the technology today, but to look on what is possible and what should be possible with the simple Hausverstand, house brain. Yeah.
Well, yes. I think the recycling industry is they are inventing a lot. So I believe they will manage with these bricks also. But as we know, building construction sector is a little bit conservative, everybody says. So anyhow, another question from Great Britain. Does the building industry need to communicate and collaborate more with the recycling industry? So I would say yes. What do you
Yes.
say? Yeah.
I think that was more a statement than a question. Yes,
Yeah.
please do. Also with manufacturing, building in this, manufacturer, designer, disposal companies. Yes, please cooperate.
I think the problem is also the very long life cycle. So what is not touching us today, as you said before, there is the problem is not now, but in 50 years. So anyhow, one more comment. Wopfinger in Mauer and Wels Baustoffrecycling Bernegger have this equipment. So these are Austrian companies. Were they interviewed too? Or
no,
sorry, because a German research.
Sorry, I don't know why, but I don't find this chat here in my view as a host. Could you please copy me this too? Thank you very much for this input.
Wonderful. So, yes, find some finalizing words now. I think. Are there any more comments? Okay, so thank you very much for being with us. Thank you very much to natureplus for organizing this series, and it's wonderful to have such an European network, so we can all learn from each other. And I hope we see us soon again. Not only at Zoom, but perhaps sometimes somewhere in the near future, face to face. But anyhow, thank you for working with us together, and we will provide some summary or slides or links for you over the webpage of IGO or the natureplus. So please stay in contact with us and have a nice evening right now. Thank you, Gondi. Thank you, natureplus. Thank you all to all of you. Bye-bye.
Thank you. Bye.